Good morning, everyone. Today we're going to be looking at Lesson 87 together. If you'll get your packets and get ready for that, that would be helpful. Looking at Lesson 87, the title of today's lesson is Multiplying Algebraic Terms. So we've learned how to add algebraic terms. We know what to do when we see subtraction of algebraic terms, but today we're going to be talking about multiplying algebraic terms. So let's just do a little bit of a recall here. I'm going to go ahead and zoom in a little bit here. Get a different color pencil. Go do blue. Okay, so let's recall. When we have been adding like terms, we know that the variable part does not change. For example, I kind of likened it to this. I said we kind of look at the X like a last name. And we have Mr. and Mrs. Quigley. So we would add our coefficients, which are the number parts of our terms. We would add 3 plus 2, and we would get 5. And our X term just transfers like this, like a last name. Mr. and Mrs. Quigley becomes 5X, okay? So the X acts as though it's like a last name. But when we multiply terms, it's a little bit different. All factors in the multiplied terms will appear in the product. So, for example, let me just go back up here for a moment. Look here at this 5x. Remember what this means. Remember 3x meant x plus x plus x. And 2x meant x plus x, right? That's what it means. It's fast adding of the same number when we multiply. And that's how we would get our 5x, 5 times x, okay? But when we multiply, take a look at what we're going to do. I'm going to take the coefficients, and I'm going to sort them out here. Using our commutative property, I'm going to put my numbers together. I would take my numbers and multiply those, my coefficients, and then I would multiply my x's together as well. So I multiply the numbers 3 times 2, and I get 6. And when I multiply, think about this. If I were to multiply 2 times 2, and I asked you to re-express that using an exponent, you would tell me that was 2 to the second power. Well, that's what we do with our x terms over here. We would take our x, take our x and raise it to the second power because we have 2 x's here. Okay, so when you multiply 2 x's together or 2 variables together, we would put the exponent of 2, meaning that that x is squared. Let's look at negative 2x times a negative 3y. So here I have 2 coefficients, and I have 2 different variables. I have an x variable here, an x term, and a y term here. I'm going to use the same method where I'm going to multiply my negative 2 times my negative 3. And then I'm going to multiply my x, whatever my x is going to represent, and my y. When I put that together, I would multiply negative 2 times negative 3, and I get 6. And then I'd have times x times y. So the answer here would be 6xy. Up here it was 6x squared. Okay, now let's look at a real live problem. Over to the right here, we're going to simplify. This looks like a lot going on, but we're going to kind of make some orderliness of it. So let's take a look at what we have. First, we're going to start by noticing that we have 3 coefficients. And using our commutative property, which means we can rearrange in any order, we know that in multiplication, we can move our factors around, and it means we could get the same answer. So we're going to pull out a negative 3. We're going to You know what, at first, I think what I'm first going to do is I'm going to pull out my negative 3. Let's go ahead and write out what each one of these means. So I have negative 3 times x times y. And then I have times, and we'll look at this term here. I have 2 times x times 2. It's a positive 2 times x. And then I have a negative 4. Times x times y. Now let's use the commutative property to put our coefficients together so that we can see how we're going to multiply this. So I'm going to take a negative 3 times a positive 2 times a negative 4. And when I do that, I have negative 3 times 2 is negative 6. Negative 6 times a negative 4 would give me a positive 24 here. Now let's go back up here and let's write out our x's. We're going to use the commutative property to put all our x's together. I have 1, 2, 3, 4 x's. And below that, what that means would be times x to the 4th power. And then finally, we're going to take our y terms, and I only see that I have 2 of those. I'll go ahead and put those here. And then down below it, you're going to have times y squared. Now, we don't leave them spread so far apart when we write our final answer. We smash them all together for our final answer of 24x to the 4th power times y squared. And that would be our final answer for that problem. Example 2, we have 2 variables here that we're looking at. We've got a and b. Some of them are squared, some of them are cubed. So let's take a look at how we're going to do this. So I'm going to pull out, first of all, my coefficients. I don't have a coefficient here with this a, do I? But we said that when there is no coefficient, we make sure that we know that it's a 1, correct? So let's pull those out. So I'm going to take out a negative 2, our understood 1, and our 3. Those 3 are multiplied together. Now we're going to go grab all of our a's. I have times a, which would be to the 1st power, wouldn't it? Times a to the 2nd power. Now in the last problem, I actually wrote out a times a for a squared, but now I'm going to leave the exponents here. And now I'm going to go back and find all of my b's. And I've got b to the 1st power right here, right? That would be like having it to the 1st power. I have another b to the 1st power. And I have a b to the 3rd power right here. Okay, now below that, let's do some math here. So I have negative 2 times 1 times 3, which gives me a negative 6. Now let's handle our a's. Okay, that was our coefficients. Let's handle our a's. Remember that we talked about being able to add our exponents as long as we have the same base. So we would have a to the 1st power times a to the 2nd power would give me a times a, which is the same as a to the 3rd power. Let's look at our b's. Times b to what power do you think it would be? Well, we have b to the 1st power, b to the 1st power, and b to the 3rd power here. That would give us b to the 5th power. Now we can write all this together for negative 6, a to the 3rd power, b to the 5th power. And that would be our final answer to that problem. That is all the examples that are going to be required to be in your notes today. There are some problems like this that you're going to be looking at in your work today. If you have any questions to any of this, please, by all means, send me a note on Edmodo. But for now, these are the sample problems that I wanted to do with you together online. If you have any questions, post them on Edmodo, and I will do my best to help you out. Have a great spring break, and we'll see you upon return.